Hi, welcome back. In this lecture, I will show you a basic implementation of the object pool design pattern. I will add a new project to this solution. First, I will add the shared object, and to this, I will add a couple of methods. And to reset its state, I will add this method called reset. This method is required to reset the shared object state before it is given to the client. Now I will add the object pool class. We need to ensure this class has only one instance, so I will implement it as a monostate. To acquire a shared object, the client will invoke this method called acquire object. And the client can return the shared object through this release object method. And we need to store the instances in some kind of a data structure. Here I will use a vector. The vector will hold the instances of the shared object. Let's also ensure we are using C++ 17 standard. Now there is one issue here. When an object is acquired by the client, we have to ensure that it is marked as used in this vector. Alternatively, in the shared object itself, you can put a flag through which we know whether it is being used or not. Now this is up to you which method to use. To keep my implementation simple, I will add a boolean in the shared object through which we will know whether it is being used or not. Now this will simplify the implementation of the object pool. If we do not use this boolean in shared object, then we have to maintain a separate data structure that holds the information of the objects that are in use. Let's implement these two methods now. In acquire object, we will first check if an existing object is available in the pool. If the pool does contain some objects, then check if they are being used or not. So if an object is not being used, then we will print a message. This is a pointer, so we have to use the member access arrow operator here. Once we know an existing object is available that is not being used, let's mark it as used and reset its state and return it to the client. Now, if the pool is empty, then let's create a new object from scratch. We have to add it to the pool. By default, the use state is true, so let's simply return this object to the client. And in release object, we will again loop through the vector of pooled objects and compare the shared object with the one that the client has returned. If they are same, then all we have to do is simply mark the use state as false. And if in acquire object you're not resetting the state, you might reset the state here. You can either reset the state here in acquire object or in release object. Let's acquire a couple of instances of the shared object. And we will release S1 object. And then acquire one more object from the pool. Now in this case, it should return the existing object. For the first two objects, the pool is creating them from the scratch because it was empty. And then later on, when we released an object back to the pool and requested another object, it returned an existing one. So this was the basic implementation of the object pool. Let's view the class diagram. So the client will not instantiate shared objects directly. Instead, it will request the instance from the object pool. In another implementation, you can make the constructor of the shared object private and make object pool as a friend of shared object so that only object pool can instantiate it. One last thing here is in the object pool, we are storing shared object pointers and the instances are created using new. So these instances have to be deleted somewhere. That's why I would recommend you use smart pointers instead of the raw pointers here. So you might either use a shared pointer or a unique pointer. So as an assignment, modify this example and use a smart pointer here. Thanks for watching. I'll see you later. Goodbye.